Hello, this is the luckiest maths teacher in the world. Thank you so much for watching as we go through two-way tables. So two-way tables are similar to Venn diagrams, which we did last time. In fact, if you're given a two-way table, you can make it into a unique Venn diagram. And the other way, if you're given a Venn diagram, you can make it into a two-way table. So what they actually look like, we have a couple of categories, just like we did with Venn diagrams. So we'll have a set A, so we put the number that are in A in this column going down here. Then the next one is not A, and then we have another category which we'll call B and not B, and then you have a row down the bottom for totals. So they're 4x4 tables, they have two categories. Okay, so again, like Venn diagrams, the benefit of them is they allow us to organize information, usually the number of things that are in a set, so that we can use these for probability calculations. So let's go ahead and take a look at an example. So you might get a two-way table like this, and it shows you two different categories. The first category, whether or not students play cricket, and the second category, whether or not they play tennis. So we have here numbers. So in this case, I'm talking about, say, student numbers. The number of students who play cricket and play tennis, for example, is 60, this number here. This number here means there are 70 people who play tennis, but they don't play cricket, and so on. So these two numbers here and these two numbers here should add to the same thing, otherwise you've done something wrong. So we could use this to answer probability questions. Let's look at a few. So we're going to use the two-way table there to answer these questions. The probability the student selected at random plays cricket, plays neither cricket nor tennis, and plays at least one sport. So let's look at the first one. What's the probability a student plays cricket? So if we look, the total number of people that play cricket is 110, and there are 210 students in total. How easy was that? We can simplify it as well. So what's the probability a student plays neither cricket nor tennis? So we just have to find the cell, the square, that is not cricket and not tennis. So that's obviously here. There are 30 people who don't play cricket and also don't play tennis. So that would be 30 over 210, and we can simplify that again. So what's the probability a student selected at random plays at least one sport? So that means they can play one sport or two sports. We don't want to include the people who play no sports. So the number there, we have 50 plus 60 plus 70. So that's 180 people that play at least one sport. Play one sport or play two sports. So it's 180 over 210. Again, we can simplify it to 6 over 7. Okay, great. I'll just do one more example now where we'll actually be given the question and construct a two-way table from that. Alright, so this is the question we'll attempt. So 40 students surveyed, and they're asked whether they go for Queensland or New South Wales. 30 said Queensland. They were also asked whether or not they passed maths. So 22 of the students who go for Queensland passed maths, and only one of the people who supports New South Wales passed maths. So we're going to draw up a two-way table and use it to find the probability that a student supports New South Wales and also failed maths. So for two-way tables, the two categories have to be sort of either or. We can't, look at which NRL team you go for, because that's 16 categories, and then we need 16 columns or whatever. You have to have two categories, and everyone is either in that category or not in that category. So let's draw up our two-way table. So we know it's going to be like a 4x4 table. And we know we've got two categories. So there's Queensland, or not Queensland, which is New South Wales. There's passed maths or didn't pass maths, which is the same as failing. Okay, and then of course we want row for totals. So we fill in the information that we do have. So firstly, we're told 40 students were surveyed. So there's 40 students, that goes there. 40 students all up. So we're told 30 students go for Queensland. So 30 goes there. And of those, 22 passed maths. So we put a 22 there. So then we're also told only one student who supports New South Wales passed maths, so 1 goes there. We can fill out the rest of the table from here. So 22 plus 1 gives us 23. So since 22 plus this number equals 30, there must be 8 students there who support Queensland but failed maths. So because this number 30 plus this number equals 40, it must be 10 students in total that go for New South Wales, which of course means 9 of them failed. So now we've done a two-way table. Now I could have easily put this in a Venn diagram. It's sort of the same idea. So I draw up my Venn diagram, but instead of having 1 for Queensland, 1 for New South Wales, I just have 1 circle for this category and a second circle for this category. So I'll just put Queensland and past maths. So the number of students who go for Queensland and passed is 22. There were 8 students who go for Queensland but didn't pass. And we can see from the two-way table there was 1 student who passed but doesn't go for Queensland. And then what goes outside the circle are people who didn't pass, i.e. failed, and don't go for Queensland, so they go for New South Wales. So you can see that each of these 4 numbers appears once and only once in this Venn diagram. So they're basically the same thing, just help us with probability. So the question was, find the probability that a student supports New South Wales and failed maths. Now we've got the two-way table, that's easy. There are 9 students who support New South Wales and failed maths out of 40 in total. So that is the required probability. We can answer a lot more questions about this as well. We can use the two-way table to answer more probability questions, but I think you get the idea now. So two-way tables, just like Venn diagrams, help us organise information to solve probability problems. So thank you for watching. This has been the luckiest maths teacher in the world. Have a nice day.